G'day YouTube, welcome back to the Osmocom-BB tutorial series. In part 2 today we are going to be covering the subject of how to build a GSM Sniffer using Osmocom-BB. There is no doubt in my mind that this installment will be what most of my viewers have been waiting for. So let's get into it, shall we? The master branch of Osmocom-BB is the version of the software that I showcased in part 1. By itself, the master branch can't really act as a standalone GSM sniffer. Yes, it can be used to construct an experimental IMSI catcher, and it can also decode 2G base transceiver station control channels. But in order to intercept our own telephone calls and SMS messages in a simulated lab environment for education and experimentation only, of course, we will need a method to capture and record GSM data to our PC. And the branch of Osmocom-BB that will assist us in accomplishing this task is called burst_ind. From here on in, I will refer to this software as burst_ind. It is also noteworthy to mention that this branch is capable of sniffing GSM downlink and uplink data, which is pretty cool. So like in part 1, let's keep the disclaimer nice and simple by simply stating, please do not use Osmocom-BB on a real 2G GSM network. Experiment with these software tools in a simulated lab environment only. Thank you. In the year of 2010, at the 27C3 Hacker Conference, a talk was given by Carsten Knoll and Sylvain Monod, demonstrating how Osmocom-BB can be used for sniffing GSM, and the burst_ind branch was showcased during this presentation. I highly recommend finding some time to watch this talk. It is very interesting and informative, and it contains a far better explanation of the technology and software tools that I could ever provide you. So let's talk about the hardware and software requirements now. We'll need for this tutorial. Most of them are covered in part 1 of this video series, so go and check that out first. All the hardware is identical to part 1, but the software differs in the sense that we are not using the master branch of Osmocom-BB anymore. We are actually going to be using the fixed area burst_ind branch. Now please be aware that compiling any Osmocom-BB branch from scratch is an absolute nightmare due to the required ARM cross-compiler for building the firmware. It took me weeks and weeks and weeks to finally compile burst_ind and the firmware images for the Osmocom-BB Calypso phone inside Dragon OS 18.04 LTS. And this is because these tools are very, very old now. So my recommendation is to just use the latest Dragon OS Focal X. Simply because the Linux binaries and phone firmware images I compiled work perfectly well on it. If you're using any other Linux distro, you will have to build and install Osmocom-BB from scratch. I won't be able to help you with that, unfortunately. Sorry. Here is the Google Drive download link to the pre-compiled burst_ind Linux executable and Calypso phone firmware. We don't need to download them just yet, but you can if you want. And the link is in the description below. So even though we covered the topic of Osmocom-BB serial cables in part 1. For this tutorial, we will strictly require a USB serial cable with a Silicon Labs CP2102 USB to serial converter chipset on board. I recommend purchasing this one from Osmocom in Germany, or you could construct one yourself using the CP2102 chip. I won't be able to help you with building one though. And we can see down here that they state that this cable can be used for the burst_ind branch. Osmocom is owned by the Osmocom founder Harold Welte. So yeah, if you purchase his products, you're supporting his awesome open source free software. So, preparation. In order to use your CP2102 based Calypso cable for the burst I&D branch of Osmocom-BB, higher, non-standard baud rates must be configured in the USB cable's serial converter chip. In order to dump raw GSM burst files to our PC storage, an increased data transfer rate between the computer and the Calypso phone is needed. The instructions of how to achieve this are listed on the official Osmocom-BB website, wiki page, but they're very, very outdated. And they do not work on newer versions of Linux. So I will instruct you on how to do it on Dragon OS Focal X. But before we continue, I must add another disclaimer. Should you choose to proceed with this tutorial, it will require you to modify your Calypso cable. There is a small risk that this procedure could brick your serial converter chip and render your Calypso cable permanently inoperable. I will not be held responsible for any mistake you make or damage caused to your equipment by following my instructions. So, if you are happy with those conditions, plug your Calypso serial cable into a USB port on your PC, unplug it from your Osmocom-BB mobile phone, and run the following command to check if it's accessible to Linux. Whoops. And we can see here that my Calypso cable is connected and accessible to Linux without any issues. So now what we will do is we will utilize a small Python application to reprogram the CP2102 chip inside our Calypso cable. And we can do that first by opening a terminal window and running the following command. Don't forget to check the descriptions down below for all the commands I run, so you can easily copy and paste them down there. So I'll just run this command and we will enter our password if required. I always configure my Linux distributions to never ask for a password because I'm not a primary Linux user. So if I damage this by running a super user command accidentally, I can just easily reinstall Dragon OS without an issue. Sorry about that. We'll just run this command again. Just ignore this warning, it doesn't mean anything. Generally with Linux, if it's in red, red is bad, but any other color is not a problem. So now, this next command, we will download the CP2102 reprogramming application into our home directory. So I'll copy and paste this. And we run that command. And we can see that a new folder has been created inside of our home directory. So we need to cd, which stands for change directory, into the program folder with this command. We hit enter. We then need to make the application executable with the following command. Now we will need to unload the Linux kernel module for our Calypso serial cable to ensure the Python reprogramming application has exclusive access to it. If your Calypso cable is plugged into your Osmocom-BB compatible mobile phone, unplug it before proceeding, and then run this command. So we will unload the kernel modules and drivers. And then we can run the dmesg command for a second time to confirm that the cable has been disconnected and unloaded from the Linux kernel. We can see that that has been successful. So now what we will do is test if the application is functioning correctly and confirm that it is successfully communicating with our USB cable's serial converter chip. So I'll copy and paste this command, hit enter on that, and we should see the terminal window printing out the current baud rate configuration and some other information here. And we can see that my Calypso cable has already been reprogrammed, and I didn't want to tempt fate by reflashing my Calypso cable to the standard configuration. So this means that your terminal output will most certainly differ to mine. So what we will do next is we will download a backup of our Calypso cable's EEPROM. This is the onboard chip where the baud rate configuration is stored. So I'll copy and paste the next command into the terminal window, hit enter, and we should see that a file has been created inside the application folder titled eeprom.hex. I recommend keeping this precious file somewhere safe, because if you have any problems with your Calypso cable in the future, you could always reflash the backed up EEPROM back onto it. So now we will actually perform the modification and add the non-standard higher baud rates onto our Calypso cable. So this next command is a bit of a mouthful, so definitely copy and paste it from down there. So I'll just hit enter on that, and almost instantaneously the reprogramming should have occurred uneventfully. Now we will run this command for the second time to confirm that the higher baud rates have successfully been written to the EEPROM. So now your Calypso cable should be matching this configuration now. So what we need to do is we need to unplug our Calypso cable again from the USB port and then plug it back in. So Linux reloads the kernel module, and then we run the dmesg command for a third time to check that the Calypso cable is visible and accessible to Linux. And we can see that we have an successful attachment and the drivers have been loaded. Excellent. I'm going to have a sip of beer. So it is now safe to delete the CP2102 reprogramming application folder if you want, but please ensure you copy your eeprom.hex file somewhere safe before you remove it. It won't hurt anything leaving this folder there, but if you're a person that likes clean file systems on your computer, you're safe to delete it. So if you're building Osmocom-BB burst IND from scratch by yourself, you'll need to add the text, I have a CP210X into the osmocom.c source file before compiling it. So because we have higher baud rates programmed into our CP2102 based Calypso cable, we can now utilize Osmocom-BB to receive 2G data over the air and subsequently dump the raw GSM burst sequences to a file with a .dat extension on our PC storage. And of course, this all happens in real time. This is analogous to recording a .c file capture of GSM radio waves with a software-defined radio and the GRGSM software, which I've covered on my channel many times in the past. Except this time, we are doing it with an old 2G mobile phone and Osmocom-BB instead. So to get started, we will need to download a zip archive from my Google Drive. The link will be in the description down there. This contains precompiled Linux executables and firmware images for the mobile phone. Now, I do realize that downloading random binary files from a script kiddie on YouTube could be risky. So in order to ease your suspicions, I've uploaded the zip archive to VirusTotal, and here is the report. The link for that is also in the description. There is a false positive being reported from Trend Micro. So to further ease your suspicions, I've scanned this file in Windows 10 on the same computer using ESET Smart Security Premium. And here's a screenshot of the results. So next, oh sorry, we've got to download it first. I'm going to save it in my home directory. So now we will proceed to locate where the web browser downloaded the file to. I downloaded it directly into my home directory, but I believe a vanilla stock standard fresh install of Dragon OS Focal X will download all files by default to downloads. So if it's not already in your home directory, locate where the file is and where the zip archive is, and then paste it into your home directory. So what we will do next is right click on the zip archive and select extract here. We will see that a folder has appeared with the title burst ind in our home directory. Browse into the burst ind folder in the file browser and open the readme file. Always read the readme file before reaching out to the developer, sending me an email, or asking questions in the comment section, please. After you have read the 4 disclaimers at the top of the text document, we can simply follow the instructions below. You should just be able to copy and paste these commands directly from here into your terminal windows. Just quickly, I should reiterate that these compiled binaries will probably only work on Dragon OS Focal X. I'm using R31 currently. And the compiled phone firmware images have only been tested on a Motorola C117 and C139. Both of those phones have the E88 Compal motherboard in them. You should check the Osmocom-BB wiki page to confirm if your Calypso phone can handle this firmware. So let's simply just follow the instructions now. So step 1 is extract the burst ind folder into your home username directory. We've done that already. So we open up a terminal window and cd, which is change directory, into the burst ind folder. Step 3 is we need to make the Osmocom-BB binaries executable, and we enter our password if prompted. Step 4 is we use the Osmocon binary to load the firmware onto the Calypso phone and enter the password if prompted. So I haven't plugged in my Calypso cable into my Osmocom-BB phone's headphone jack on the side here, so I'll proceed to put the 2.5mm stereo jack into the headphone jack of the Osmocom-BB phone. And then we run the command to download the firmware into the phone. And then the Osmocom binary is standing by for us to power on our Calypso phone, so I'll go ahead and do that now. The firmware is just writing to the RAM now. And then we have a successful boot of the custom firmware. And I have layer 1 Osmocom-BB printed on the screen, so that's really nice. So step 5. Oh yeah, sorry, I forgot to mention that you can use this command here to find the label of your Calypso cable. It should just only be TTY USB 0. And if you plug a second cable into your computer, that will be TTY USB 1, so on and so forth. So we'll open a second terminal window now, which is step 5, and cd into the burst IND directory. Sorry about that, guys. I'm back. Just had some minor technical difficulties again, which is perfectly normal when you're working with Osmocom-BB. So let's start from step 6 again. Use CCCH scan binary to scan ARFCN 975 and dump GSM frame bursts. Enter password if prompted, and change the A argument to the desired ARFCN you are trying to capture. I'm not going to explain what ARFCNs are. Most people watching this video should understand how GSM downlink, uplink channels work by now. So yeah, we've already got this command pasted into the terminal, so I'll just hit enter on that. Now, if everything goes to plan, we should see a single line of blue text in the CCCH_scan terminal window, indicating that a system information type 1 packet has been received from the target GSM cell. CCCH_scan is now listening for 2G traffic to capture and record. So if I proceed to turn my Samsung S9 smartphone off flight mode, this should generate some traffic on the GSM cell, and immediately we can see the terminal window populating with lots and lots of red text. This is a very good sign that CCCH scan is doing its job correctly. Inside of our burst IND folder, located inside our home directory, we should begin to see one or more numbered files with the .dat extension. These files can range in size from a few kilobytes to several hundred kilobytes and into the megabyte range and beyond. This is dependent on how much traffic is currently flowing across the GSM cell and what kind of traffic it is. There we go. More technical difficulties. I'm back. It was working perfectly before. I didn't pray to the demo gods, obviously. I'm just turning my Samsung smartphone on and off flight mode to generate some traffic. So we can also see that some lines printed in the terminal output have the letters UL in them. You might be able to see them. These are uplink packets from my Samsung phone being recorded and dumped to GSM burst files. Burst IND is capable of capturing downlink and uplink signals simultaneously. But please be aware that due to the onboard RF filtering of the Calypso phones, the 2G uplink signals can only be received from very close range. Maybe you could receive your neighbors, or if you're in an apartment building, maybe the people above and below you directly, but not much further than that. Working with these burst files is not as straightforward as decoding a GSM C file capture with GRGSM, but it is still possible to do. So hang around to the end of the video to find out if there will be a third installment of this tutorial series covering how to handle these captured burst files. Okay, I'll just quit the CCCH scan binary and I'll just show you a few things. So if you're getting the dropping frame, we're going to talk about some troubleshooting, sorry. So if you're getting this dropping frame with 76-bit error, which will happen often, sometimes I'll absolutely flood the terminal window and it will feel like you are not accomplishing anything. So we can do the previous trick that I was doing before, where we can send the Control-C keyboard shortcut and quickly run the command once again. And you might have to just keep doing that until it works properly. There's another error as well, but I can't find it in here. But let's see if we can trigger the error. Actually, if I quit my GSM base station, I've just triggered the error. So if you're experiencing this error, which is FBSB RESP result equals 255, this is indication that the Calypso phone has become unsynchronized with the GSM base transceiver station. This can be rectified by sending CCCH scan the Control-C quit keyboard shortcut and running the command again. You may have to run the command one time just to resync with the 2G cell, or you may have to run it 10 times or more. Just keep trying. And if you're sometimes it can feel like Osmocom-BB will just not work at all. And when that happens, we can always resort to the old trusty, have you tried turning it on and off again meme. I love that show. The IT crowd? Yeah, that's it. Quit the Osmocom binary with the Control-C shortcut. Quit the CCCH scan binary. Power off your Calypso phone. Disconnect the serial cable from the phone and the PC. Reboot your computer. Plug everything back in again and restart Osmocom-BB burst IND from scratch. So yeah, now that we have reached the end of the video, you may be wondering what exactly can be done with these recorded GSM burst files anyway, that have been dumped from our 2G base transceiver station. This is a very, very good question, and it will probably require an entirely separate video of its own, because this current video has well overstayed its welcome at this point. So, naturally, please stay tuned for part 3 of this tutorial series in the coming weeks. I don't think I'll be able to do it within 2 weeks, unfortunately, guys, but we'll do our best to make sure it's all ready to go. So when I have the time to record it, I can record it and upload it for you all. So yeah, thanks very much for watching. Bye.